Srinivas, welcome. Good to have you. I remember talking to you a couple of days back, and a very passionate person you are. Some of the articulations you made on LinkedIn, I was telling my team, he seems to be somebody who is taking this not just as business, but as something that is his passion. Srinivas comes with more than 20 years of work in biogas. When I went through his resume, I saw that not only has he worked across the entire value chain of biogas, the biogas production, I saw that he has also been tinkering around with microorganisms and stuff like that for a while. Is that correct, Srinivas?
Yes, yes.
So yeah, maybe you are just what the doctor ordered, so to say. If people are looking at innovations, research, etc. So we would like your thoughts, Srinivas. You've been in this field for a long time. Infrastructure and costs, they are hotly debated topics, especially the later one, costs. I'm hearing so many numbers, which is fine. I mean, for an industry, its initial stages, there will be some uncertainties, but people would like to listen to folks like you who have been in this business for quite some time to get some valid estimates. So over to you, Srinivas.
Yeah, thank you, Narsi, and thank you for the introduction as well. And has rightly said that I have spent more than 2 decades in the industry, being associated with the early pioneers right from 2007 onwards, who were into installation of the first and second bio-CNG projects in India. And many were then followed, and even policy decisions were made on those plants. And quite a number of good plants have been installed by me and my team. And presently, I'm representing Arka Brainstick, where hello, it's audible, right?
Remind before ending to download chats and you was telling no.
Hello.
Hey,
yes.
I think there is some noise. Can we avoid it, please? Srinivas, go ahead.
Yeah. So I was just about to 1 second. My presentation is visible, right?
Can we have his presentation, please? Srinivas' presentation. You may want to wait for a moment.
Yeah. Meanwhile, I can just go through. So has informed that we are into biogas consultancy, and we give consultancy to the people or the companies, entrepreneurs who are venturing into this business of biogas. And this is the right question, as Narsi has pointed, that many people are not aware about the cost of the project, or the you can say the cost of the biogas plant, or the difference between the plant and the project. As rightly said by all my fellow speakers since morning, I have been listening very patiently, and Joseph Hans has also pointed out that many things and many parts, including the equipment selection, combined together will give you a different project cost altogether. So when it comes to project cost, I would like to go step by step. Okay. Initial is pre-feasibility followed by feasibility. Then comes your laboratory or the lab equipments, which almost 90% of the people who are getting into the business don't want to buy laboratory equipments or don't want to spend any money on labs, which is I don't feel is the right thing to do. Because when you talk about laboratory equipments, and when people are not ready to spend money on laboratory equipment, just imagine that how they are going to install the plant. So this is how it is. So we have to understand about whatever money we need to spend on laboratory, because everybody relies on, suppose if it is press mud related TS, VS or anything related details, we have worked right from 2007 onwards. I particularly have more than 7 odd papers published on press mud. So people keep on referring, but
telefonkonferenz, så jag tror må vi ett skrot. Nekaj kina.
I think Hans, can I request you to put your speaker on mute? Yeah, mic on mute. Yeah, thank you. So, when people still rely and depend on the test reports which are available online, and they don't want to spend any money, and press mud or any feedstock which is completely different in the northern part of the country compared to the southern part of the country. Same goes for your napier grass and paddy straw. So, coming down to your the cost, we can divide the project and make it as a very simple process by pre-treatment section, gas upgradation section, digestion section, feedstock, and the biomanure section. Once you divide these sections, every section has different technologies which we would be covering. Okay, the next slide. Yes. So I will be explaining you in detail all these slides. So just when we talk about pre-treatment, yes, exclusion method is also available. Steam exclusion, enzymatic process for sludge or for different types of raw material. Starch enhances degradability. Then when we talk about other types of feedstock compared to napier grass and feedstock, the technological feasibility needs to be understood across the feedstocks, not only on that particular feedstock. Coming to the digestion section, yes, there would be dry digestion, wet digestion, high rate technology suitable for different types of raw material. People are combining, just they are not able to understand what is which technology, and they are blindly following up what other people are installing. Like nobody is interested in understanding about the technology. CSTR, if somebody has spending X amount of money, then they blindly want to copy and target and want to reduce the price. And India being a cost sensitive country, forget about technologies, forget about everything. Everything boils down to the cost. So, as rightly said by Narsi, the cost is ranging for a 5 TPD 12,000 cubic meter biogas generation plant, right from 15 to 45,000, 45 crore. So, I will let you know what would be the ideal cost by the end of my presentation. So, coming back to the gas upgradation, yes, H2S removal, there is a cost based on your feedstock. Again, we need to understand what would be the size of inlet as well as the design capacity. Again, you need to understand about the final upgradation cost of whether it is membrane, PSA or VPSA, or what type of PSA it is there, whether it is 20% losses, 30% losses, 35. I have visited projects where people are giving 35% losses from the system. So you need to understand that if you are installing the PSA, the heart of the system, the molecular sieves, what or how much amount of molecular sieve needs to be added in the system, whether the entire equipment has working and standby equipments in place, because projects are installed in such a rural areas and or remote locations that if anything spoils down, then nothing can be worked for next 2 3 days or 4 days or a week if there is no standby equipment in place. Similarly, our manure thing, whether the bagging unit is considered, whether the liquid storage or the slurry, whatever is coming out of the digester, whether it is considered for single day, 2 days, 3 days, 10 days, 30 days, or what are you going to do with the liquid slurry during the rainy season? So these are the questions I always ask my people who come to me, unless and I clearly tell them make a list of the questions. I have quite a number of articles online about the cost as well. So you can simply make a list of questions, and once the questions are answered, only then move to your installation part. Okay, so capex and opex for that particular equipment, and then the further needs to be understood. Next slide, please. So along with this, the qualitative scales, what to expect from the technology suppliers. We need to understand that the qualitative scales, cost comparison, feedstock selection, technology selection, and the capex and opex. So capex and opex would be the last final stage unless you do the equipment selection, feedstock selection, and technology selection. Everybody, whoever comes to us, they think that napier grass is available or paddy straw is available in abundance, but there is a difference between the availability of the raw material in that particular area and availability of the raw material for the project. So unless you have the agreements in place, unless you need to understand that the raw material is available for the project for 365 days, don't jump into the project. So feedstock selection, based on that, you have to select your technology. Of course, the selection of the technology will be based on the Opex and Capex. So again, this point, when I talk about technology selection, people are doing the same mistake. Entrepreneurs directly ask the technology supplier or the person who want to install that, please select the technology for us. So when he's supplying a technology, how can he do the technology evaluation? So these things have to be understood very thoroughly before you approach or approach any technology supplier or a company. So all these questions need to be understood. That selection of techniques and technologies for both pre-treatment, digester, biogas generation, as well as your biomanure and upgradation needs to be in place. So whatever technologies are available, I have listed down. Just you have to do the evaluation by understanding the critical equipments along with Opex in terms of maintenance, and what would be the long-term life cycle analysis of that particular technology or equipment. Next slide, please. So when we talk about Napier grass, yes, again there is a question about. I have seen various reports like my colleague Mr. Patil was mentioning that people come to me saying that we can grow 600 tons per acre, 800 tons per acre, and a very very vague figure. So it's completely disturbing when we see such type of figures in terms of raw material growing as well as the gas generation. So when we are continuously promoting, like Mr. Shashi Hegde has been very proactive, and he's very active as well as he's promoting, and he's now at least disseminating the knowledge to the people, common man, that the Napier grass cannot be, you should never expect more than 150 to 180 tons per acre. So this figure, when he brought down to that level, now people have, when technology suppliers have started increasing the gas production. So they have started showing that you can grow you get easily 150 to 200 or 250 cubic meter per ton of Napier gas. So all these figures depend on n number of factors. Okay, so the same gas being generated from some other plant, you cannot copy, because the selection, the technology selection, equipment selection would be completely different. On an average, you can understand that 80 to 110 cubic meter per ton of Napier gas can be generated per cubic meter of gas. Similarly, for paddy, it ranges between 250 to 350 cubic meter per ton of paddy straw. But again, you need to understand that what would be the total solids and what is the volatile solids, along with the pre-treatment section. Whether the pre-treatment section is designed for that particular feedstock. Okay, so yes, the Napier grass of 5 ton CBG generation for one particular technology and the equipment selection would be completely different when you compare with the other technology. Even if the same technology from different latitudes and altitudes, it would be different. So one has to understand the cost, how the cost is differing. Rather than just reducing the cost, you need to understand that don't cut the cost for the equipments which are required and must. It has to be added or included. Okay, cut the cost where you don't have to worry about, it is not hampering your efficiency of the digestion, or getting more gas out of the digesters or your upgradation system. So the biogas generation from paddy straw is significantly higher when I say or compare with Napier gas. Yes, that difference is because of the total solids and volatile solids. Okay, you're comparing 90% with almost 25 to 30% TS. So that's where it is 3 times, and yes, the TS is 3 times. Paddy straw has a feedstock fairly shows very poor degradability in availability and technology feasibility when you talk in terms of silica and other factors, along with less suitability for biofertilizer making and less suitable choice for a viable biogas plant, I must say. Okay, so coming down to your feedstock characterization and the selection by accessing different parameters. I think next slide, please. Yes. So coming back to the feedstock selection, I can say that biogas yield come along with that degradability, nutrient content, accessibility, and the technological feasibility or technical feasibility. So these are the points where we need to understand whether the system is going from low to high. So these are the factors that no entrepreneurs or people who are getting into the business are looking at. So there are several kinds of feedstocks, mainly different types of raw material is available. Yes, but again, each feedstock has a different biogas generation potential, and all of them can be mapped across the these 5 parameters which I said, that biogas yield, degradability, nutrient content, geographical and physical access or the accessibility, and the technical feasibility. So when I talk about biogas yield, yes, it refers to the amount of biogas generated by that particular feedstock in terms of cubic meter per ton of raw material. It When I talk about degradability, yes, the degradability curve needs to be understood based on the retention time, or don't only look at the high rate or low rate of digesters. You need to understand the degradability curve as well. So it signifies whether the feedstock is easily degradable and suitable for anaerobic digestion, or is it not digestible and has inhibitory effects as well. Okay. Coming back to the nutrient content, which was touched by Sai from RDD Dynamics, that it refers to the NPK content in the biogas generated from the feedstocks. Okay, we need to understand what are the raw materials and what would be the C by N ratio, phosphorus in that, and based on the feedstocks and their suitability for biofertilizer. So not only if you one of the expert was mentioning about adding micronutrients and trace elements in the digesters are preferred. Yes, but again, one has to look about whatever you are adding to the digester will come out in the form of your slurry and your organic manure. Whether if you are adding chemicals to adjust your C by N ratio or your pH, then the same chemical traces would be found found in your nutrient content of the organic manure. So one needs to add or select the technology very carefully. So this is all about technical feasibility as well, but it determines whether a sound and mature technology to process the feedstock exists or the technology is in the nascent stage. So just don't blindly visit the plants and understand that plant is installed so we can also run. Understand that once the plant is installed, it has to go through a commissioning phase. Then comes the stabilization phase. So after commissioning for maybe 1 to 2 months, stabilization would be around 2 to 3 months. Stabilization is where you are ramping up the plant to the design capacity. So if you are installing a plant at 100 tons per day of raw material feedstock to the digester, ensure that 100 tons is fed to the digester for pretty long period of at least 3 to 6 months. Then you can evaluate or consider that technology. Don't only blindly look at the gas generation from the cow dung seeding and the culture and just be happy from the commissioning part and get away out of it. So next slide, please. So when I talk about project number 1 of the plant developer and plant developer 2, yes, there would be huge difference when I see the pre-treatment methods as well. Only the pre-treatment methods will show us different project costs, because there would be mechanical pre-treatment. Yes, again there would be exclusion. Okay, so these two are completely different. Your Opex would be completely different, your Capex would be completely different. So one has to select the both the technologies along with the feedstock. Yes, both the places you have the paddy straw, but the Capex requirement for extrusion is higher than the mechanical treatment. Therefore, the increase in the cost of the Capex can be seen. So the yield from the extrusion is, yes, also significantly. It ranges from 15 to 20%, but again, has compared to the mechanical process, but justifying the increased project, whether it is justified or not, whether the added amount to the Capex and Opex, you are getting that amount of gas or not. So we need to understand that whether you are there to do some R&D or you want a business model where you can start earning money. So this is the other way around, where most of the technology suppliers or the companies are doing R&D with the entrepreneurs' money. So don't fall for that or become a prey. You need to understand that whatever is proven has a long track record. Just install that and understand how you can take that forward. Similarly, I can say that paddy straw cannot be compared with press mud. When you want to have a extrusion, yes, for paddy straw and napier grass it might work, but for press mud it will never work. Okay, so these are the small things you need to understand. And when I talk about pre-treatment technology, pre-treatment techniques, next slide please. So it is very simple. One has to understand the complexity of that particular raw material or any raw material. Okay, the most complex is the lignin part, followed by cellulase. Then comes your fats and waxes, hemicellulase, proteins, pectins, starch, and sugar. Sugar is in the last stage. So based on these complexity, you have to divide your raw material and the pre-treatment technology. So pre-treatment technologies are very simple. It is bifurcated in 4 different stages, I can say, or groups, which is physical, chemical, biological, and you can say a combined. Like people are doing steam explosion or thermochemical. They are combining both the technologies. Biological is very simple. It's either microbiological, enzymatic, fungal, or any type of treatment which doesn't need any capital cost. But yes, you need operational expenses for that, because operational. Next slide, please. Operational expenses is very much important. So you need to understand that what type of pre-treatment you are giving. When it comes to chemical, yes, alkali or acid treatment or oxidative is there. Physical is mechanical, chemical, ultrasound, electrochemical, or the fusion of 2 different types of technology. So every category, or I can say that every feedstock is treated with a different pre-treatment technique. So you cannot blindly follow that the same pre-treatment technique might work for other feedstock. Okay, so these methods are either temperature and pressure sensitive and have distinct chemical processes or cost viability, I can say, and they have where they had to be performed. So although more than one method may be suitable for one type of feedstock, the distinguishing criteria can be either capital and operating expenses along with the maintenance required. So based on that, the biogas yield will be differing. So one has to do the selection very carefully. I think next slide, please. Yeah. So when you see the paddy straw and napier grass or press mud, we can say that lignocellulose, which has lignin present and increased surface area, you need higher the surface area, better would be the degradability. Energy demand would be lower the energy demand, interferes reduce operational cost. So homogenization or maybe inhibitory information. So you also need to understand that when I was talking about chemical treatment or thermal pretreatment, which may lead to formation of internal inhibitory affecting degradability. So inhibitors, you need to understand that when you're increasing the temperature, yes, it is not like very simple that you can run your digester for few days on thermophilic, then you ramp up to mesophilic, which people are trying, and I don't know who are giving such crazy ideas that the inhibitory effect can be seen, and within 6 months everything will stop. So it is very difficult to understand different feedstock and their demand for operations. Okay, next slide, please. Yeah, so this slide on the left would be very much interested to all the people who are looking for the cost point of view. So I have bifurcated physical, chemical, biological, and combined processes. Okay, so when you see about mechanical, thermal, and ultrasound and electrochemical, which falls on the physical treatment, I have shown that 5 to 10%, yes, and for ultrasound and electrochemical it is 10 to 15%. So based on that, yes, no doubt the gas production would be increased, but you need to understand that along with the gas production, the Capex and Opex is also increasing, and there would be some maintenance when you're talking about any equipment, any machine. Yes, there would be a maintenance on longer run. So also you need to understand the life cycle analysis of that particular equipment. If the equipment, whatever you're using for ultrasound, if it is 7 crores and has 3 crores of your operational expenses, there would be maintenance, maybe overhauling maintenance, or if you're lucky, then instead of 3 to 4 years, it might be 5 years, but there would be some maintenance for sure. So all these factors need to be catered in, which people are just ignoring. And I have seen people coming to me saying that, sir, the income is from a 5 TPD plant is so much that we can get our payback within 2 years. But I would like to tell everybody that whoever is getting into the biogas field, that no project in the country has shown payback less than 5 years. So project will be somewhere between 5 to 6 years. You can say the payback would happen, and 6 years is the accurate figure if you can consider in your projections. Then that would be really good, and you can say realistic figure rather than going on the figures which are just boosted on Excel sheet to make sure that people and the bankers are happy. So 6 years is the payback period. So make your mind whenever you're getting into the field, and these figures are just the ballpark figures considering various capex costs, like even for civil, mechanical, electrical, and the capex and opex are, yes, associated with different technologies. For 12,000 cubic meters of gas generation, raw gas generation, which is equivalent to around 5 TPD of CNG from that particular feedstock. Okay, next slide, please. So again, coming back to our suitable conditions inside the digester, all our colleagues have already explained, but I just want to touch that, yes, robustness of the process as well as failures, design and automation needs to be understood. Again, one has to understand what would be the uh, co-digestion, okay, whether the co-digestion you have considered or not, whether the combustibility, compatibility or energy consumption of that particular technology you have understood. Water requirement is very key, so you need to understand that whether you need to add some water or remove the water from the system. All these parameters, your mass balance, your complete end-to-end, your details have to be in place before selecting any technology. Yes, coming further, it would be either dry digestion, wet digestion, and hydrate digestion. These are the three criteria for selecting optimum digestion technology. So based on that, you can understand whether we have to go ahead with wet digestion, dry digestion, and hydrate digestion. Digestion technology, I can say that, if everything is considered, right type of agitators, the number of agitators required, whether if you have done your complete calculations, if it is PFD analysis is done and if the agitators are in place, then yes, I don't see any play problem. Temperature maintenance and your double membrane roof. So double membrane roof has to be at least, you need to understand the calculations. I have visited few projects where the 32-meter die is showing only 1 or 2 meter height of the double membrane, which I particularly don't accept and would not, allow these kind of things to happen, at least for the entrepreneurs with whom I am associated with. So anything less than 6 meters or 6.5 meters is not accepted for a digester like that. For 32-meter dia and 9 meter or 8 meter height, and you are having a dome of 1 to 2 meters is not acceptable. So that's where the cost difference is. Company A is quoting you for 8 meters double membrane roof. Company B is quoting you only 2 meters double membrane roof. The agitators like Joseph and Hans was clearly mentioned that if the digester requires four number of agitators, people are quoting only two or three or different types of agitators, saying that your gas circulation can mix and different types of agitators can mix. So whenever you select any agitator, you need to understand what would be the operational expenses of that particular agitator, okay, along with the capex, and just have a comparison. And before entering into or buying the equipments, you need to understand end to end along with the replacement and spare parts. Then you select the technology. Next slide, please. Yeah, next slide. Yes, this is very. So this again, I try to explain, which I'm sure that everybody is very keen to understand about what would be the project cost or what would be the overall plant cost. So as I said that there is a huge difference between a plant cost and a project cost. Okay, we are talking about the bill of material. So when it comes to the project cost, yes, n number of factors like your working capital, your interest during construction, your preliminary expenses, pre-operative expenses, your all these combined, and when come together will become your project cost. The bill of materials also, you need to understand that yes, I just said that whatever slurry is coming out of the digester, whether you have calculated for 30 days, 60 days or 90 days, because you need to understand and take care of the slurry. Second part is when you're talking about digesters, whether sufficient number of digesters along with equipment selection has been done. Third is your gas storage. When it comes to the CBG, final output of the CBG, suppose you're installing a 5-ton CBG plant, I have seen that people are only providing one cascade of 400 or 500 kgs, which is a very I can say it's not acceptable by the industry norms. But you need to understand that as a project owner, you have to compare whether 5-ton CBG you are generating, whether 2.53, 3.54 tons of CBG storage is associated with that particular project. Already the costs are catered in or not, because whatever the technology supplier will supply with n number of exclusions for him will have to be included by the owner or the entrepreneur of that particular project. So you need to understand that when you're installing a project, all costs have to be included rather than exclusions and inclusions. So just to bifurcate a cost, this I have given considering all the automation, wiring, fabrication, civil works, complete end to end by any good technology supplier. So when you talk about CSTR with less than 20% 20% PS content, yes, I have given a ballpark figure of capex, which should be around, you can directly multiply the 6,500 cubic meter with the amount of gas you're generating, which is equivalent to 12,000 cubic meters. That will give you a ballpark rough estimate. Similarly, I have worked out all the detailed costs for Opex and operational expenses as well as maintenance expenses. But I deliberately have not shown those expenses over here because, again, as I said that, right from your plant, feedstock storage, harvesting machine, when you talk about napier grass, when you talk about your vehicles like, tractors, trolleys, vehicles for transporting CBG, vehicle for transporting your manure, whether all those things are considered or not, whether the fire system is considered or not. So based on that, I can give you the operational as well as maintenance cost as well. But this is just the digester or the digestion section cost. So just to give you all an idea, I cannot give you the entire project cost, but I can say a thumb rule for a good project. If we want to install, where almost 90% of the Indians are comparing the German technology and German plants as well as Japanese plants, then you have to keep in mind that 6 crore to 6.5 or 7 crore per ton of CBG is your ballpark figure for any project up to 10 tons. So if you're going for 5 tons, then 5 TPD plant, then you have to understand that it will range between 6 to 7 crores. That would be the ideal project cost considering everything. So when I said considering everything without any exclusions and included everything. So you need to understand that once the bill of material is ready, then the chances of getting the vague cost or the wrong cost would be hardly, there would be a difference of not more than 5%. So one has to understand that the projects, whatever you are installing, have to be installed like an industry, like fit it and forget it types, rather than uh, projects people are installing it and every year they are spending more money to operate and maintain rather than taking home. So it's almost there. Those projects will never be. You will never see a payback even after 12 years. So one has to understand that when you're designing any project, consider all the aspects and everything in the project itself. Next slide, please. Yeah, biogas upgradation, I think my colleagues have already covered, but I would like to just touch base that, raw biogas will go to the biogas scrubber. Yes,
Srinivas, if we can finish it in the next couple of minutes so that
yes,
we
yes.
can have some time
Just
for
2 minutes.
Q&A. Thank
Just
you.
2 minutes. Just 2 minutes. So the biogas, again, biogas scrubber, dryer, biogas upgradation unit, there would be n number of technologies, right from H2S removal, your CO2 removal. So based on that, your cost would be completely different and vary. Next slide, please. Yeah, biomanure. So this section I have seen that yes, a few people are worried about the biomanure section, but nobody wants to consider the costing. As I said that whatever digester, whatever feedstock your slurry you are feeding into the digester, there will be similar amount of slurry coming out of the digester on daily basis. So consider ample amount of storage on site, the liquid slurry. Again, you need to separate it. Yes, you'll be using some part of the liquid, but some part of the liquid has to leave the system. But you have to answer me what will come on during the rainy season. So you have to consider that time along with solid manure, whether you want to do prom, whether you want to do bagging unit, whether you want to dry, whether you want to compost, to consider all the aspects and everything. Only then you will have the solid manure. So solid manure will not come directly from the digester in the form of solid manure. So you need to have that process in place. For process, you need to consider the cost. So this is the most neglected part in the biogas industry, particularly in India. So the process of composting, drying, pelletization, there would be like vacuum evaporation, membrane filtration, precipitation. Then comes your wastewater treatment, whether that particular feedstock requires any wastewater treatment plant to be in place. So all these things will combine and will give you different types of capex as well as opex.
We have a lot of questions. I would have liked somebody else to also involve themselves in Q&A, but perhaps I can take it this time. A lot of questions once again. Of course, these two teams, one from JNF, the other from Marka, I think they covered something that everybody is very, very keen to know. Of course, the topic is around lignocellulosic feedstock, but eventually the key questions from investors come to, okay, kitna deta hai, how much can I make, what is the payback period? So firstly, thank you very much. I think it was an intensive last 1.5 hours by you two teams. Firstly, thank you very much. Lots of questions have been put down. There have been a couple of questions I have had as well. Maybe I should go to Srinivas because yours is something where I'm sure many of these guys are having it in their lips. So let me shoot it out. You mentioned 6 years as a more conservative number you would take when it comes to pre-treat, when it comes to payback period, correct?
Yes. Yes.
Now, this is for what? Conventional MSW based thing, or is it for the paddy straw kind of project you're talking about?
So basically, I was targeting paddy straw as well as napier grass plants because the cost of the raw material people are assuming at a very low level, low price. Secondly, the operational expenses, whatever I have seen, I have been invited as a third party investigator as well as by a few of the financial institutions. So I can see the cost of the operational cost which people are assuming or considering. It's way very less or very low. So almost I can say that 50% to 60% or somewhere between 45 to 55% of your revenue would be your operational expenses when you're targeting these two feedstocks or raw material.
No, I mean, in fact, I'm saying it looks very good to me, 6 years, because many times when I do the numbers with some of these guys, I would have actually happily taken 6 years. It comes to much more than that. Maybe I'll come back to slightly later. It looks like Hans has to move on. So why don't I go to Hans and then come to you? Is that all right?
Sure, sure,
I
sure.
have a follow-up question on that. So Hans, thank you. Thank you for joining us all the way from Germany. You guys finished your presentation with German precision precisely at the allotted time. Very good. It's so good to see so much of work you have done. There are questions that have been put up for your presentations. The slides has. Let me see what best I can choose from that so that we use the time very well. You mentioned about cane trash in one of your examples that you had mixed with press mud and spent wash. Now, how successful was this project?
Yeah. I'm on mute, I think. Okay, so I tried to stop this because in that case in Brazil, the mixing system was not able to mix a good mixture of these feedstocks. So if I remove the cane trash, I could increase the capacity of the digester drastically. Because the cane trash, the fibers, increase the viscosity so crazy high that the additional gas yield I couldn't realize because I had to put much more spent wash to keep it mixable. It's just a question of mixing of the digester. It's a question of using the right mixing system. In that case, the decision was make the spent wash with the press mat and it's fine and you have the best gas yield.
So, in hindsight, would you recommend cane trash as a partial feedstock at all or not?
I would prefer to use cane trash as single feedstock, mono fermentation of cane trash.
Okay, so
perhaps with straw because it's very similar, but cane trash normally is available in big amounts in the sugar mills, so you should do it as a mono feedstock. You can design the plant directly
all
on the
right, got
trash,
it, got it. Because
and
in
it's
India as well, we have, as you know, India is along with Brazil one of the leaders in sugar production.
yeah.
We have a lot of cane trash, and it has not been valorized very well. That was one question I had. The second was you had also mentioned in one of your slides that there was a Napier grass plant that you had put up, though it was smaller in scale. Was there a pre-treatment for that Napier grass plant, or was it fed directly? How was the construction?
For the Napier grass is a fine, nice energy crop. It's very similar to the feedstocks we use in Germany. It's not so simple than maize silage, but very similar. What I'm using is triticale, is clover grass and other types of grass, like Sylvia, an American prairie grass. Very similar to that. That's simple to digest. The question is how to harvest. We harvest mechanically, cut it to 10 to 20 millimeters, make silage from it, and from there we directly feed it into the digester. No additional pre-treatment necessary.
Wow, that's very
It gives
interesting.
no sense. If you do it, you will waste money.
So the Napier grass you are talking about in Germany, Joseph, is it something similar we have in India? Is it a different kind of a Napier grass? If it doesn't require a pre-treatment in Germany, does it require one in India? Any ideas? Any of you guys, Srinivas or Joseph?
Yeah, so grass per se, the Napier grass, when you look at the DM and ODM consistency, if you've seen the grass or maize grown in Germany, so they are closer in terms of the nature actually. Of course, the gas yields are completely different. The ODM and dry matter, the organic dry matter is quite high in maize. The gas yields are quite high in maize. But what's happening according to our understanding is many people are using so-called wet. That's a very generic term to use, but a submersible agitator or a recirculation pumps. So if you want to feed into such digesters, what you have to do is you need to pulverize it or pulp it, or they don't use a solid feeding system. There is no solid feeding system for the reasons which Srini was saying. They again think it's expensive and adding some long-term equipments or robust equipment is expensive. So they have to pulp it, pulverize it, and then pump it into the digester, for example. So, but even in Germany, a typical so-called wet fermentation always has a solids feeder. That's solid feed is something, the concept is not in India, because it was again, one plant before 12 years came in Varna, like, everyone saw the pre-treatment in a mixing pit, and that became a standard that everyone tried to do the same thing for the years. And I know Srinivas is laughing because he knows this as well. So that has become a standard that, everyone does the same thing, same thing, same thing. So in short, I mean, the Napier grass per se, doesn't need this pre-treatment if you're shedding it and taking it in a right size into the digester. As Dr. Ann said, harvesting is the key. How are we going to harvest? I'm not sure if that's kind of figured out in most of the cases, but people need to have proper harvesters to do this job. Yeah.
Last question to Hans, just in case you want to make a move on. You had also shown us large piles of press mud, where you mentioned that the covering of press mud is a very important component. There was a question from somebody, and they said, whatever you do, the press mud, there is going to be some sort of anaerobic activity, and it is going to release biogas. What is the point in covering it?
So we must stabilize the press mud. So we must avoid that composting processes removes the digestible organic. That can be done by this ensilaging process. So it's a lactic acid fermentation, which happens everywhere. You can put bacteria in or not, doesn't matter. If you compact the material and avoid oxygen or air coming in and coming on the surface, you avoid this composting process. You get this lactic acid fermentation process. This drops down the pH and stabilizes the material. So to keep the gas yield in, compact it and cover it, and you're fine. If you don't cover, we lose the upper 1.2, 1.3 meters as a good quality feedstock.
Got it. Thank you very much, Hans. Those are all the questions that are directed directly to you. Just in case you want to move on, was a pleasure having you with us. And I'm sure India is going to see a lot more of you as we go along. Thank you.
Thank you very much.
So, guys, a couple of more questions to you guys, and then we can probably wrap this up. Lots of questions, as I mentioned. One for Srinivas, continuing with it. You see, can you take a couple of more minutes?
Sure,
The
sure.
you see, we had worked out for some of our clients some numbers, and they're not looking very good. I mean, at the current rate that they are getting from the OMCs, even if I add a bit to the fertilizers and stuff like that, it is difficult to see. And the cost you guys are talking about, 6.5 crores per ton per day. I'm not getting 6 7 years. It's going to towards 10 years or more. So I'm just wondering, maybe we are missing something.
Yes, sir. We can discuss one-to-one whenever you are available. So based on that, I can guide you. And yes, there would be another good news to the industry, maybe in another 2 or 3 weeks. Price is going to be increased for the CBG. So let's wait and
Very
watch for
good.
the good news.
That can help. That was one. As I said, these are questions I'm not expecting all the answers right now, rather putting the seeds in your mind, because these are questions I ask, these are questions I have. I'm sure there are people who want to ask the same questions to you face to face. Let me just see what are the questions I had put for you. Yeah, the current projects, two questions, both related. One, what are the current projects you guys are involved in CBG per se? And secondly, is there any Napier grass uh, in those projects?
Yes, we have been associated with JSW Group. So it's a group from JSW, and they have been doing extensive research and study from past 3 years. Okay, so I have been particularly on their board as a consultant and representing them. We have already installed one plant in Punjab, which was about to commission, but due to the farmers' protest, it got stopped. And we are installing one more project in Maharashtra. And whatever I suggest or I believe is in a small, as normal projects rather than mega projects, what everybody is talking about 10, 15, 20 TPD. Because yes, generating gas is not a problem, but what are you going to do with the feedstock? Feedstock management, as well as your organic slurry, as well as solid organic manure management. So that is still not in place, but people are talking about 20 TPD, 40 TPD of CNG, which looks very vague for me. So I target 2.5 to 5 TPD, not more than that. And several projects have been associated. Like one of my project would be commissioned in another 30 days from now. So January 15 to 20, we are going to commission on press mud, and similarly one project on Napier grass again the same day. So maybe within a month's time, we would be commissioning both the projects in Maharashtra.
These are going to be based on
Press mud and Napier. Press mud and Napier.
so
Napier grass.
these are going to be mixed together, Napier grass and
Yes.
press mud together.
Yes.
And what? Okay. And related question, since you spoke about guys being very ambitious with their capacities, what do you think is an economically optimal capacity in terms of tons per day?
So anything between 2.5 to 5 TPD is good. Don't look at the Excel sheets or the numbers which you are calculating on Excel. You will never be able to match those numbers, and it will be only on Excel sheet. So you need to understand that whatever efficiently you are operating the plant at 90% or 85% CUF, then yes, it's a wonderful achievement in the biogas industry. So nothing is 100%. So you need to take care of that as well.
And you mentioned also, if it is going to be a 10 TPD plant, it's going to be 6 to 6.5 crores. So what we are talking about for that plant, 60 crores to be put in?
Yes. Yes, sir.
But I'm just last question. I know I know some of these have to be answered face to face. You see, if I put a paddy straw or a napier grass, I'm going to get maybe 5 to 7 tons, or maybe even 8 tons per 100 tons of the feedstock. Whereas if I put in MSW, it's going to be 3 to 4 tons. So are we still sure that you are getting double the yield in the case of paddy straw? But are we saying that then the capital cost is going to be shoot up dramatically from the use of MSW to paddy straw? You get it right, because you are quoting capital cost in terms of crores per ton.
You are calculating two different raw materials, where MSW is completely different feedstock, where you don't have to pay for the raw material. You are getting the raw material for free. At the same time, you are getting the tipping fee on the second part. When you're talking about paddy straw, yes, you need to have already the prices at a premium level now, which is ranging from 2 rupees 50 paise to 5 rupees already touched. So all these factors pile up and will give you a different payback period. So raw material, when you talk about paddy straw, again pre-treatment is a must. But in case of your municipal solid waste, normal pre-treatment or hydrolysis is more than sufficient, rather than any costly extrusion or any of mechanical physiochemical treatment. Okay. Secondly, you're comparing 16 to 18% total solid content with 90% total solid content or 85% total solid content. So this is where the figures are ranging. So we need to bring down every aspect on the same page, and that's how I've tried to bring the gas price to the project cost, so that per cubic meter cost was derived by me, so that it would be very easy for the entrepreneurs or the people to understand that yes, across the feedstock the price would be completely different, considering different pre-treatment techniques or your equipment selection.
What I take back from you, Srinivas, and I think that's a very important message for all you guys here, because I know a large percentage of these guys, 118 fellows I see here, large percentage of them want to invest in it, is, look, all these are ballpark numbers, metrics, but there are so many variables. I think unless you sit with guys like Srinivas or anybody else who is putting up a plant and take maybe a week, taking all the inputs into consideration, you are never going to get a number which is close to reality. This general metrics, plugging them into a spreadsheet and getting the results is useless. So I think that is what I take from him. Well, the questions I asked him also, it is clear to me that that's probably not the best way to ask the question. Yeah, the question itself has to be framed differently, and then the numbers pan out very differently. I think that's the message I take for me as well as to all the investors. We have to sit with these guys case to case basis. What is the feedstock? What is the technology we are going to use? And finally, look at where the numbers lie. And also, obviously, we have to put in some numbers on what percentage of the fertilizers we can sell. Unless we get all these, I think we are all just talking very random numbers. And when you're going to invest hundreds of crores, it's a bad idea to track random numbers. Thank you, Srinivas. Thank you for your time.
Yeah. Thank you, sir. Thank you for being here today, as well as I wish you, as well as the entire team, whoever is present, a very good evening. And it was an honor to present my perspective here today. So thank you once again.
Thank you, my friend. Thank you.
Thank you, sir. Thank you. This was a very interactive session.